Hello everybody, and welcome to Business Calculus. If you're watching this video, I'm assuming you're a class member of my Business Calculus class at Central Michigan University. If you're not, you're still welcome to watch. You are going to be missing out on some of the things that we're doing in class. If you would like those, feel free to email me and I will see about getting them to you. Now, since this is the first video lecture that you will be having for our class, I'm going to be just doing a little bit of review on stuff that you should know already. Primarily for this video is function review. We'll be talking about the definition of a function, what an inverse of a function is, and what piecewise functions are. These are all things that you should already know. So I'll make this quick. First, the definition of a function. Most of you already have heard of functions before. So this is a little bit of a wordy definition of it, but a function is a relation between a domain and a range, also known as a codomain, such that for every element in the domain, there's only one element in the range that relates to it. So, for a simple two-dimensional equation, such as f of x equals x, there's only two variables, x, which is part of your domain, and y, which is part of your range or codomain. So that means for every x, there's only one y. Now, your domain can have multiple variables, so that is why we're using this definition. So if it's the f of xy equals x plus y, well, your domain is made of the x's and the y's, and your range will be made up of a third variable, usually referred to as z. Now, a simple way to test if something is a function is when you plot it, use the vertical line test. Many of you should have already heard of this before, so it should not be that difficult to do. Now, I have said f of x, that is function notation, which is given by here f parentheses x, close parentheses. It does not mean f times x. This is one of the biggest mistakes that often happens. I do not want you guys to be making this mistake. What it does mean is the function f evaluated at x. So for an example, if you have f of x equals x squared plus 2x, we want to find out what f of x plus h is. So we're going to be evaluating our function at the value x plus h. So we take x plus h and put that in wherever we had an x before. Now we see our new equation, which when we simplify it out, comes to this ugly mess. Now, what are inverses? Well, many of you have dealt with inverses before. There's multiplicative inverse, additive inverse, and there's also functional inverses. Additive inverses are the easy. You just throw a negative sign on it. So the additive inverse of 2 is negative 2. The additive inverse of 3 is negative 3, and so on. Multiplicative, you just do 1 over your number. So the multiplicative inverse of 4 is 1 over 4. Functions are a little bit more complicated. So the inverse of function is based on which operation is being used. Now, when I say the word operation, that should immediately imply to you either we are talking about adding, subtracting, multiplying, dividing, or using exponents. So whatever operation we're using at any time, we want to do the opposite. So additive, they need to add to 0. Multiplicative, multiply to 1. And composition is the way we find inverses for functions, which when you compose the two, they need to come out to x. Whenever we're talking about the inverse of a function, we mean the composition inverse. We don't mean find the additive inverse of a function. That's not going to do it. So let's take a look example. If we have the function f of x equals 2x plus 1, well, the first thing it does to our function is multiply by 2, and the second thing is add 1. To counter that, we have to go in the opposite direction, doing the opposite thing. So we'll want to subtract 1 and then divide by 2, which gives us this function f inverse of x equals x minus 1, all divided by 2. And now, decomposing, which we see to the right, gives us that they both come out to the same thing of x. Now that is key, that it has to come out to x from both sides. Now, keep in mind, whenever you have an inverse, it should be undoing what was done originally. If you were adding before, you should be subtracting for your inverse. Multiplying before, you should be dividing for your inverse, and so on. Now, what do we mean by piecewise functions? This is the last major aspect of functions that we need to know about. A piecewise function is a function that is defined by different functions on different intervals. Sounds a little clunky, but it's not that bad. If we look at this, it looks bad, but it's saying f of x is defined by the function negative 2x plus 1 for x less than or equal to 0. So on our xy plane, when x is less than or equal to 0, we're graphing that top equation. Our second half says f of x is equal to 5x minus 3 for x greater than 0. Well, that means is on the right half of our xy plane, where x is greater than 0, we have this function 5x minus 3. So it's defined by the first function up to and including 0, which means fill in the stopping point. So when you evaluate it at 0, we'll get f of x equals 1. So we'd have the point 0, 1 filled in on our graph. Then when we evaluate from the second function, it's for values greater than 0, which means you find out what the value is, but don't fill it in. So when we put 0 in here, we'll get point 0, negative 3, which should be an open circle. Whenever you're dealing with this, you always want to make sure you stop and end at your boundary values that you are given. If you draw one of these and you start the second line at 1, we have an issue. Now here are a couple exercises that I'd like you to try out. I'm going to give you a few moments, so try it out.